Today we're going to continue to look at slope-intercept form, a continuation of some of the aspects that came up in last chapter. So slope-intercept form of an equation, if we have a line with slope m and y-intercept b, is y equals mx plus b. So some of the examples that we saw last chapter, for instance, y is equal to 3x plus 2, where 3 is our slope, so that's the number in front of the x, and our y-intercept is 2. So, write an equation of the line whose slope is 5 and whose y-intercept is negative 6. So remember, we have y equals mx plus b, where m is the slope, so I'm going to plug in 5 for m, and then b is the y-intercept, so plus and then a negative 6. So I can leave it as plus a negative 6, or I can rewrite it. Y is equal to 5x minus 6. So either one of these two answers would be appropriate, depending on whether you like plus a negative or minus 6. And the same thing for this next example. M, the slope, is negative 2, and the y-intercept b is 3. So y is equal to negative 2x plus 3. When a graph clearly gives you a y-intercept and another point in the line, you can use that to write an equation of the line. What we're doing is making a rise over run, making a right triangle to help get the slope. So again, two ways to find slope. One is rise over run. Take the rise, how far up or down does it go, and then take how far left or right it goes. Put those as a fraction. You can do that numerically by using the ordered pairs and subtracting the y values, putting those on top, subtracting the x values, putting those on the bottom. So, in these examples, let's get an equation for this line. So right here we have a y-intercept of 1. So that's going to help us because that's part of the equation. So all we need to find now is slope. So another point on the line is right here. And that's at 1, 2, 3, 4. 1, 2, 3, 4. So that's at the point 4, 4. There is another point on the line. So I can make a triangle to use rise over run. My run is 1, 2, 3, 4. My rise is 1, 2, 3. So slope, which is equal to rise over run, is 3 over 4. Now to show what that would look like calculating it, my 2 points I have are 4, 4 and 0, 1. So if I were to do the rise over run as the y2 minus y1, I would take these two ordered pairs. I'm going to call this one the second one and this one the first one. So y2 is 4 minus the y in this first one, which is 1, over x2. The x comes from over here, and then the minus the x in the first one, 4 minus 0. So 3/4. So either way, by making a triangle and counting how far you go over, or by calculating it using the y2 minus y1, both gives us the same slope of 3/4. So our final equation is y is equal to the slope times x, so 3/4 times x, plus the y-intercept, which is 1. Here's another one. Something we should point out right away is this one should have a negative slope because it's going down as we go to the right. So there's our y-intercept, 1, 2, 3, 0, negative 3. So our y-intercept is equal to negative 3. Now we have to find our slope. So another point in the line here is at 4, -1. So again, two possibilities. We can make a right triangle. The rise is -2. The run is 1, 2, 3, 4. So rise over run is -2 over 4, which is -1/2. And again, if you wanted to calculate it using the points 4, -1 and 0, -3, call this 2, call this 1. So y2 is -1 minus a -3, or minus a negative is the same as plus, and then 4 minus 0. So -1 plus 3 is 2. 4 minus 0 is 4. Okay, quick correction. This should be the point -4, -1. So we should make this a -4, which would be -4 minus 0, which is -4. And that gives us our slope of -1/2. So our final equation is y is equal to -1/2 x plus a -3, or -1/2 x minus 3.